Good morning to one and all present over here. Today we are on our third lecture of circular motion. So what we have planned is that this is the third lecture and we'll try to finish it by the fourth lecture. Okay, so one more week to go. Then we'll start a new chapter, that is work, power, energy. Then after finishing of that chapter, we'll do center of mass and then we'll start rotation motion. Okay, so this is not a very big chapter and it doesn't have such weightage in JEE Advanced, but for JEE Mains it is perfectly fine. But still, the questions which are still important for JEE Advanced, I am still trying to make it. Okay, and I am also providing the PDF in the description and in the pinned comment box. So today what we are going to study is, first we'll recall one question which is very important, and we'll focus on one JEE Advanced PYQ which has came recently. So let's begin. So today let me tell you a short thing, that we know that in our kinematics, we have studied about displacement, we have studied about velocity, we have also studied about acceleration. And in circular kinematics, what we studied are angular displacement, angular velocity which is omega, and angular acceleration that we denote by a Greek symbol, that is alpha. So we understood this, but for our recapitulation, let us again just taking a brief theory of this. So in kinematics we previously learned that if we want to get our velocity, if we are given displacement as a function of time, so what we did is we just differentiated the displacement with respect to time, as we are given the displacement function of time. So if we wanted the acceleration from our velocity or from displacement even, we can find. So what we did is dv by dt, which gave us acceleration. This can also be written as the second order derivative of the displacement. Now, so let me write it in a better way. So we just differentiated to get, again we differentiated to get acceleration. So now if we are given acceleration and if we want to find velocity, so what we did is the opposite process of differentiation, that we integrated it. Okay, so what we integrated, we know that dv by dt is equal to acceleration. So we can write it that v dt is equal to dv is equal to a dt. Now taking integration both sides, we can see that this integral will give us velocity, so which will equal to the area of the acceleration and time graph, if we try to visualize it by graphs, or we can simply say it is the integration of acceleration with respect to time. Again, in similar way, we can also say that integration of ds is equal to integration of vdt. In junior classes, like in class 9, we have also learned that, we have also memorized, right? We have memorized that the displacement is the area of velocity time graph. So this is the reason why displacement is area of velocity time graph. So these are the things for our kinematics which we have studied in our previous chapters. Now let's come to circular kinematics. So in a similar way, we can say that differentiation of angular displacement with respect to time will give us angular velocity, and again differentiation of angular velocity with respect to time will give us angular acceleration, or we can also write it as the second order derivative of our angular displacement. So we can also write it like this, that when we differentiate theta we get omega, and if we differentiate it again or find the second order derivative of angular displacement we get alpha. Now let us reverse the process. So d omega by dt is equal to alpha, or we can say that d omega is equal to alpha dt, which is equal, so taking integral both side, this term will give us omega, which is equal to integration of this. Okay, so similar answers we are getting, just we are changing the values of this v, a, and these are only changing, but everything is remaining constant. So in this case also we can write that integration of d theta is equal to integration of omega dt. Okay, we can write it like this. Also if we say that we want use graph, then we can also find out that theta, which is equal to the area under the omega and time graph, similar as the velocity time graph. So these all the things we recall. Now one important and very small topic is that which we have already learned in kinematics, okay, which in JEE Mains questions are asked from that, so we must learn that. That is, in kinematics what we studied, that if acceleration is constant, then we have derived Newton has derived three equations for motion, that are v is equal to u plus at. This is the first equation. Second equation is s is equal to ut plus half at square, and the third equation is 2as is equal to v square minus u square. So this is the first equation, this is the second equation, this is the third equation. Okay, we have completed our this all derivations. Okay, in 9th class we learned how to derive these all equations graphically, and in 11th class we studied it how to derive it with help of calculus. So the same thing but different. In 9th class we just found the area, like let me show you for v is equal to u plus at. Once let's recall. So suppose this is a velocity time graph. Okay, this is the velocity time graph. Let's consider a particle having an initial velocity at time is equal to 0. Can you see? If I tell you to mark the coordinates of this point, what we'll say? We will say that time is 0. Okay, so x value we write first, that is 0, comma u, because this distance, which is the velocity, it is in our y-axis, so we write it like this, 0 comma u. Now we know that slope of velocity time graph gives us acceleration, and let the motion be a uniformly accelerated motion. So what our graph becomes, it goes like this way. Okay, we say that acceleration is linear, or we can also say many other things. And this point, let us consider that the time at this point is t naught. So first we write our x value, that is t naught, comma, let's consider this as v, which is our final velocity. So these coordinates become this. Now we know that acceleration is equal to slope of this velocity time graph. So to find the slope, we can also, so now we can write in different form. We can find the tan theta, we can differentiate it, and there are many other equations for slope which we learned in our further maths class in the chapter straight line. So for now I am applying the most basic formula, that is y2 minus y1 divided by x2 minus x1. I hope that you know that why it is so, because we are taught in our basic classes of physics that why the slope, what is slope, what is, how they are found. So we are taught, we already know this basic formula, okay, which is this is equal to m, which we say slope. So y2 minus y1, that is y2 is this and y1 is this. So v minus u divided by x2 minus x1. x2 is this and x1 is this. T naught minus 0. Simplifying this, we can also write that at is equal to v minus u, or v is equal to u plus at. So in 9th class we used to derive like this, but when we reach 11th class, what we did, that we know that acceleration, what is acceleration? It is dv by dt. So can you see the same thing? Here we just wrote the formula, which the very basic formula, but here we are just differentiating it. So now we can say that dv is equal to a dt. Now integrating it, so how I will integrate? Our initial velocity was u and our final velocity became v. So we'll integrate in this manner. Our limit will be this. In the initial velocity, what was our time? Our time was 0. Our time was 0. And what it became, as we are integrating it with respect to time. Okay, so acceleration will be also a function of time. Okay, understanding? So what will be the limit, what is the minima and maxima, is it should be related to the time only. This we have learned in basic integration. So it is going from 0 to a time which is known as t naught. So let us complete this here. So integration of dv gives us v. The limits are, which is equal to a dt. Okay, which is equal to a dt. So here a is given as a function of time. So we'll just integrate, we'll just put the values, and what we get is a t. Okay, from this integral what we get is a t after putting the limits. So when we'll put 0, automatically it will become 0, and when we'll put the time as t, we'll get this value. So this becomes, we can say that v is equal to u plus at. This we learned in 11th class. Like this we can derive all the equation, but for our basic concept clearing, I have showed you this. Okay, so in very similar manner, in circular kinematics, what we can do is, in circular kinematics, if angular acceleration is constant, I hope you understand the meaning by acceleration has to be constant, because can you see that in the first equation acceleration is there, second equation also acceleration is there, and third equation also acceleration is there. So acceleration is common in all the three equations. So we can't apply for variable acceleration, right? If acceleration is 1, then it becomes 2, then it becomes 3. So how can we apply these equations? We have to then find for each and every points. I hope you understand the meaning. Okay, so if the acceleration becomes constant, then we can only put one value and we'll get this all. So acceleration has to be constant. In a similar manner, if angular acceleration is constant, the first equation which becomes is omega final is equal to omega initial plus angular acceleration into time. Just putting what we did here, we put v is equal to omega final velocity here is omega final. Okay, u is equal to omega initial, and angular a is equal to alpha. So we are just putting, you can say, okay, you can say in one respect that we are putting it. So similarly, second equation becomes theta is equal to ut, means omega initial into time plus half into alpha and t square. Our third equation becomes 2a theta, 2 alpha theta is equal to u final square minus u initial square. So this all the equation which comes up, and they are important for our JEE Mains. Okay, there are many questions which are asked in JEE Mains, so we'll talk about it later on. Now, from the previous lecture, I want to discuss and I want to recall a question which was a very good question and which was given in the previous class. So as the duration between two classes are very long, so I am recalling it once. So what was our question is that this is a turntable. This was a turntable. This was the center of the circle, this turntable. At a distance r, a mass is kept at a distance r from the center. A mass m is kept, and this whole turntable is rotating with a angular velocity that is constant omega. Okay, here friction is present, which is not equal to 0, so we can write mu is not equal to 0. This is the top view of the question, top view. Okay, suppose that this is the circle. Okay, I'm not having any disk, so understand it like this. This is a circle, and this is the surface on which this mass is moving, like this. Okay, like this it is moving. So I am viewing it like this, in this way. I am trying to view. Another type of, let me give you, that is side view. So how our side view will look like is like this. This is moving with omega. This is the center of circle. R distance, at R distance mass of m is kept over here. Okay, so it is rotating in this manner. See, you can say it is rotating in this manner. This is in rest, but here I can't rotate the book, so this is in rest and this system is rotating like this. The disc is, or the turntable is rotating with omega, and this is in rest. So we are told to find the maximum value of omega such that our block remains at rest. As we see that friction, which is mu, is not equal to 0. The coefficient of friction is not equal to 0. So there must be a friction present. And so what we'll do now, first step is to find the center. If you want to write the equation of motion, first step of ours is to find the center of the circle on which the object is rotating. So our center of circle is this. Second step is that we have to make the FBD of the block which is rotating. So this is our circle, this is the mass, this is r distance. Okay, and this is moving with omega. So for FBD, what we can say that a mg force is acting downward, normal is balancing, and it is acting perpendicularly upward direction of the block. So as here the ball is at rest and it is not moving in our vertical direction. It is not moving, it is not changing its position in the vertical direction. So we can say that in the vertical direction the block is in equilibrium, and whenever the block is equilibrium, so we can say that normal is equal to mg. So for now it is of no use because it is equal to mg. Now let us understand that if this is equal to mg, then what is the force that is acting towards the center? So as we are told in this question that mu is not equal to 0, so it must be the friction force at which is acting towards the center. Now there are two types of friction we have studied in NLM, Newton's law of motion, okay, and in the friction chapter separately. So here we are told that the block is remaining in rest. Block is remaining at rest. So what will be the friction? It will be the static friction. And what is the value of maximum static friction? That is, the static friction can be maximum mu into mg. Okay, mu into normal, which is equal to mg. In this case, mu normal is mg. So this is the maximum value of our static friction. So the maximum value of static friction will be applied in this case because the block is in rest. So let us now solve the question. Now the forces which are towards the center is equal to mr omega square. Here r is a smaller, so let us write smaller. Okay. So now let us write it in a simplified. Maximum value of static friction is mu into mg, which is equal to mr omega square. Now if this is, now we want the maximum value of omega. Okay, so in this case also we have to take the maximum value of static friction, that is equal to this. So just simply we can say that omega is equal to m gets cancelled, mu g divided by r's root over. This is the value for omega at which the block remains at rest. Maximum value of omega. I am stressing in the word maximum because it is important for our clarity of concept. Okay, this maximum concept. Have you understood? I hope you have understood. Okay, now let us go to our next question. If you have understood the previous question, you will be able to understand this question, because this question was asked in JEE Advanced, but still we'll use the previous concepts and some basic concepts. So I am repeatedly telling you that please don't skip any concepts, because there are many small concepts which are present, but the small concepts are used in various ways. In solving big question, small concepts are only used. That is the basics. So clear your basics. We'll practice question. Okay, you can try any book. You can practice question easily, but we have to focus on the theory part. There are different people who prepares for IIT differently, prepares for NEET, prepares for UPSC. Okay, if we study it in the right way, in the correct way, so we are not to prepare it differently, right? Because the syllabus is same for all these competitive examinations. So if we study it correctly with our clarity of concepts, if we clarify our concepts basics, if we make strong, then only we will able to solve any question, whether it is of NEET, whether it is of IIT JEE, whether it is UPSC and many other competitive exam. So let us see our question of JEE Advanced. So in this question, what it was said is that a circular turntable has an starts from rest and it accelerates to a constant angular acceleration, that is alpha, at time is equal to 0. So first what they are saying, that there is a circular turntable. Okay, again this is the top view. This is the center of the circle. This is R. This is our mass. Okay, so there are it is basically, there is a whole paragraph of the question, you can check it too. I don't remember which year it was asked, but there is a whole paragraph describing these all things, so I skipped, but I focused on the main part. At time is equal to 0, these all things happened, and it is rotating with an constant angular acceleration. Okay, I hope till here no problem. This turntable is a friction. It is having friction. Okay, it is a non-frictionless surface. So up to here are clear. Now the next part of our question says that find the time at which the block of mass is about to slip. So this is the language of question. You can read the language, okay, if you want. Now let us first think what is happening in the question. So now it is moving with the angular acceleration. So first we have to visualize this case. What is actually happening? The block of mass is again at rest. The turntable is rotating. Okay. So have you ever observed a fan? When we press the switch, it starts from rest and then it rotates with a less angular velocity. Then its angular velocity gets increased after a certain time, and then it becomes constant, and with constant angular acceleration it rotates. Okay, so the same case is, we can say that it is happening in this case. As it is having angular acceleration, we can say that this block will have a tangential acceleration, and of course as it is doing a circular motion, it will have a centripetal acceleration, right? It will have a tangential acceleration because the magnitude of the velocity, which is speed, is changing as this is accelerating. Okay, so first it was at rest, then it got increased, and finally it achieved a certain final omega, okay, final angular velocity or something like that, you can see. So what is happening to the block? In this direction the tangential acceleration is acting, and in this along the towards the center, centripetal acceleration is acting. Now we can write what we can write from here. We know that our tangential acceleration value is equal to r alpha. Okay, r is the radius of the circle, r alpha, and our centripetal acceleration is equal to mr omega square or mv square by r, but here we are given this, so I am writing it. Now let us understand that these are the values, but if a tangential acceleration is acting in this direction and centripetal acceleration is acting in this direction, so our net acceleration would go here, somewhere here. This will be our net acceleration. Okay, a net. I am representing it by a net. Here we will see, if we try to make our FBD, we will see that here again normal is equal to mg, because it is moving in our, okay, it is moving in a plane, in this plane, but it is not moving in either this direction or either this direction. We can say that it is not changing its position in the y-axis, so it is in equilibrium, so we can say that normal is equal to our mg. So this both gets cancelled and you can understand it. But here friction is not equal to 0, so there a friction force will be applied, but the question is that in which direction it will be applied. So as the resultant of these two vectors is towards this direction, that is the direction of our that is the acceleration net. So what we can say that if our acceleration is on this direction, then in whichever direction there is acceleration, the net force acts on that direction only. So the force net which is acting on the block will be on this direction. And what is the force net? The force net here is our friction. Okay, I hope you are clear with this. Now let us consider that this this is making an angle, suppose theta. Okay, theta from this. Then what will be the value here? Value of the force, that is here in this direction it will come F cos theta, and in the perpendicular component, the component will come F sin theta. So we completed the first two steps, that is we found the center, we broke the force in the perpendicular direction of the object and in the direction towards the center. So now we are to complete our third step, that is the force which is acting towards the center should be equal to mr omega square, and the force which is acting on our perpendicular direction will be equal to, this force will be equal to m into acceleration tangential, as tangential acceleration is acting on this direction. So its value is equal to mass into r alpha. So mr alpha, its value is equal to. Now we have got two equation, and what we can do here is we can take the squares of both and we can add it. Why we are taking squares of both? It is because if we take as we can say that f is common in both the equation, f is common. So if we take the square, what we'll get, that we'll get f square cos square theta in the left hand side of the first equation, and in second equation what we'll get, f square sin square theta. So if we take f common, then cos square theta and sin square theta will become 1, and then we can directly find a relation between friction and the right hand side of our two equations. So let us write squaring both sides and adding 1 and 2. This is the 2, okay, 1 and 2. So what we get in the left hand side is plus f square sin square theta, which is equal to mr omega square whole square plus mr alpha whole square. Okay, up to here I think it is clear. So f square will be coming out common, and we can write it cos square theta plus sin square theta after taking out common, and here we will say that mr omega square whole square plus mr alpha whole square. So this is equal to 1. Okay, now I am erasing this the language part so that I can utilize this part also. Now what we are left with is f square is equal to mr omega square whole square plus mr alpha whole square. So our f becomes under root of mr square whole square plus mr alpha whole square, right? This is what our f becomes. Okay, up to here we are clear. Now we are told to find the value of the time at which it is about to sleep. Okay, it is about to sleep. So after that time, if more it is rotated, then what will happen? It will fall down or something like that. We have observed whenever anything is stuck on our fan, we just switch on the fan, and automatically when it is getting some angular acceleration, and after some time when it is rotating with such angular acceleration, after a few time it falls down. So similarly in this case it will fall down. Okay, but in that case it is a very complicated, because friction is acting, then air resistance is also acting, so it will be a complicated version of this question. So this is what our static friction becomes. Okay, now I am erasing this diagram. So what I want to write here is that we know omega final is equal to omega initial plus alpha into t. Now what was our omega initial? We were told that it was at rest, so the motion started at rest, and our final omega becomes this. Okay, that we don't know. What is our final omega? We don't know. So I am removing this part, as this value is equal to 0. Alpha into t. So what does our time come out? Our time comes out omega final divided by angular acceleration. So from this equation, what we need to do, we need to find the value of this omega, then we'll find the value of alpha, and then we'll just put the value of alpha and omega to get this answer. Right everyone? I hope the question of advance is easy. Now you see that whenever you will try to find out the omega value from this case, the value of omega is coming really complex value, not complex value, but the calculation is becoming complex. So this is the specialty of JEE Advanced. The question is easy, but see, let me show you. So if we want to find the value of omega, what we will do is, first you need to remove this under root. So we'll write fa squared, which is equal to this value. Okay, so I'm directly writing it that if we move this side, so it will be equal to r alphas whole square. Okay, now this value will be getting into under root divided by mr, and this value is equal to omega square. Can you see from here? Omega square is there. Then again we'll apply another root over. This value will be equal to our omega. Okay, so this is the specialty of JEE Advanced, that they make such complex mathematical calculation. Okay, or if some informations are asked, that what will happen in this case and what will be happening, we can find out, but these are only what we are to deal with. So from now also, if we start every day just 10 minutes, if we devote for calculation part, we try to multiply things, we try to divide things, we try to find the under root of different values of decimal values. If we try, just give me 10 minutes every day, so we will able to improve our calculation, and it will be more easier for us to calculate these all things. Okay, so this was our JEE Advanced question. I hope you liked this discussion of this question. Now let us move on to our next article, that is the question based on the road. Okay, now we are trying to find out the application of circular motion in our daily life. So Now we are trying to relate circular motion with our daily life. So now road problems. This article is favorite article of JEE Mains. JEE Mains. Their favorite. Okay, and already it has been observed that 10 times in last 5 years, 10 times question are asked from this particular article. So we must see it, we must not skip it, because it is important, and it is also important that, and it is also expected that it will come in future, it will come in our future examination of JEE Mains. So suppose this is a circular path. Suppose this is a circular path and a block of mass is kept here, or a car, you may say a car. Now I will say that friction is not equal to 0. That means there is some friction. This is the center, and so now we are to make the FBD. Okay, we are to make the FBD, that is mg acting downwards, normal acting upward, and in this direction what is happening? Friction is acting. Okay, now this block is moving. This block is, what it is happening? It is moving, and friction is acting in this direction. So what we can say that friction is equal to mv square by r. In this case, I don't think that omega will be given, because we will not told that the block is in rest and the road is moving. It will not told, right? So similarly will be given velocity in some direction. So we'll apply this mv square by r. Now, what is the value of friction? That is mu into normal is equal to mv square by r. From here we can just substitute the value of normal. Here normal is equal to mg, because it is not changing its direction in the y axis, it is not changing its position. So mu mg is equal to mv square by r. So we need to find the maximum velocity. Here what we need to find is the maximum velocity. Okay, here a friction is acting. Now you suppose that you are moving with a very high speed. So what will happen is, you will have a tendency, your car will have a tendency to skid. Okay, it may happen that it is having a velocity, so it will go in this direction only. It will go in this direction. The similar way, okay, we observed, right, that whenever there is a circular motion, the velocity of point is tangent. Suppose it is moving in like this, so the velocity is tangent, so the car will just move in a tangent path to this. Okay, so this we have to understand. So there will be more chances for the car to skid. So what will be the maximum value of our velocity? Because here we are taking the maximum value. Now again, see, understand, it is having a tendency to go out, get out of this circular path. It is having a tendency, but still it is not going. So the block is not going, right? So we have to take the static friction, not kinetic. Many people will say that it is rotating, so we'll take the kinetic friction. No, it can't be. Yes, kinetic friction will be acting, but kinetic friction will be acting in this direction. Okay, in the opposite direction of the force which is applied, or something like this. Okay, we have seen it in NLM where we saw that where, but in this case, as we are talking that, as we want to know that whether it is going, it is skidding, or it is continuing its movement in this circular path. So it is continuing its movement. But after this velocity, if it exceeds this velocity, then it will skid. It will skid. Here we are taking the maximum value of static friction. So here we get the maximum value of velocity at which this friction will be maintained, or we say this is the maximum friction which will occur when the car is moving with maximum velocity. Okay. After if the velocity becomes more, then what will happen? Kinetic friction will start and it will move in this direction. Car will move in this direction. So what our Vmax becomes? It is becoming, mm gets cancelled again. So what it becomes is mu gr under root. So this is the value of our this. Okay. In this case, what we are considering, that in the track mu is equal to 0. So in the circular track mu is equal to 0, but in this case mu is not equal to 0. Okay. So this we are assuming as of now. Okay. So here mu is equal to not equal to 0, and this is the case which it becomes. Okay. Now our next article for today is banking of road, which is also asked in JEE Mains. Banking of road. So now there will be coming two formulas which we have to remember, or which we have to try to remember. So in the previous case, what we observed is the Vmax was equal to mu gr. Okay, this was equal to mu gr. Now we have studied in Newton law of motion and friction that this mu is the angle of repose or the angle of friction, as we have studied. Repose. This is the angle of repose. Okay, this is the angle of repose. And we also found out that this value is equal to tan phi. Okay, tan phi. So for example, if the value of mu is 1 upon root 3, then the phi will become 30 degree. Okay, the phi will be becoming 30 degree, as tan 30 is equal to 1 by root 3. So phi will become 30 degree. Okay, so just we'll substitute the value of mu and we'll write that tan phi. So this is the velocity maximum when the friction in the track is equal to 0. The friction in the track is equal to 0. So this is a hypothetical case which can't be possible in our daily life, but still we are considering it as we are asked question in JEE. Okay, so we are considering it. It is a hypothetical case. It will not come, but still we are observing. Now, what if friction is there? If friction is there, friction is there. So I will make two cases that what should be our minimum velocity. It may happen, okay, it may happen that our car may get, it should have a minimum velocity, right, and a maximum limit should be there. So also in the hilly areas we see that many boards are written Okay, boards are there in which they say that the maximum limit is 20 kilometer per hour. 20 kilometer per hour. Okay, like this there are many boards which are written, so they are for that purpose only, so that we don't get any accident or do any accident. So here there are two formulas. First is for our velocity maximum. So the formula which is gr tan theta plus alpha. This is the formula for our maximum velocity. Okay, and for minimum velocity what happens? Minimum velocity, it becomes gr tan theta minus phi. This is the minimum velocity. So now let us try to visualize it. Suppose it is this book is inclined like this, and it is making an angle with a horizontal theta. Okay, now try to visualize that what is this banking of road, and if a object or car is moving in like this, it is moving, object is moving like this, it is moving in this direction, like this it is moving, like this it is continuing, and it is again moving. So I've often seen the racing cars, or when the drivers drive, or the cars which are there in hilly areas, so they always have a inclination like this, and they always move in this. So try to visualize this. Okay, so what is happening, that let me show you, that when we make FBD, the normal will act this direction, and the mg will be acting to this direction. Okay, mg will be acting downward, and the normal will be acting perpendicular to the block. And of course, as we are studying the banking of rod, which is a real life application, so there must be friction. Now the maximum students make mistake in finding the direction of friction. So we have to understand that we want to find the maximum velocity. Okay, so in case of maximum velocity, what is to be understood is that we are told to find maximum velocity. So if this maximum velocity exceeds this limit of maximum velocity exists, so can you understand, can you feel it, that it is always the friction on this ball is always acting in this direction, in the tangent. Okay, friction is acting this, which must be static, because it is the maximum value. If the value becomes more, then kinetic friction will start. So this car or this block is having a tendency to move outside. It is trying to move outside the circular path, but it will not move. It has to maintain this track. So static friction will act upon, and this will happen. So let me make a 2D diagram of this, and I will try to derive it. Let's derive it. So this is an inclined plane whose angle is theta, and here the block is, now it is moving like this. I hope you are understanding it, because I already gave you the 3D explanation, so it will be easier for you to understand. So it is moving like in this way. It is moving in this way. Okay, now as we have studied in inclined plane, we have done many questions on LNM. So if the mass is m, normal will act this side, mg will be acting this side. Now this is 90 degree, so this angle will be 90 minus theta. Okay, this angle will be 90 minus theta. Now try to understand the tendencies of the block is always outside. First case, I am trying to find the maximum velocity, Vmax. So the tendency of the block to move is always outside. It is outside. Okay, tendency is outside. So it wants to move outside from the circular track. But it can't move. It can't move because the this is moving in the circular path. So it should be the maximum value of our static friction. Now, as this angle is 90 minus theta, okay, as this angle is 90 minus theta, so our, now let us try to mark the center. Okay, this is the center. As this is 90 minus theta, this whole angle is 90 minus theta. So again, this angle will be equal to theta, so that the sum of these two angles becomes 90 degree. Now let me enlarge it. This is the block. Okay, this is our center. Friction is acting in this direction. This is the mg. This is our normal. Normal is always acting perpendicular, in the perpendicular way. Here this is perpendicular, right? This angle we are also told that this is theta. So again this will be also theta. So if this becomes theta, then what will happen? This force will be equal to F cos theta. Okay, this force is equal to F cos theta, and the force which is acting in the direction of mg will be equal to F sin theta. So two components we made, and also the normal is acting in an angle. Okay, so we have to make the components for normal also. So you can see that this theta and the friction and normal is making 90 degree. So if this is theta, this will be equal to 90 degree minus theta. So if this is equal to 90 degree minus theta, then in this direction what will act is n sin theta, and in the above direction the component will be n cos theta. So I am making the components easier to understand. Okay. Mg is acting downwards. Mg plus what is acting? F sin theta is acting downwards. This is the block. It is kept in this way. So Mg is acting in the upward direction. What is acting is n cos theta. Okay, only n cos theta is acting in the upward direction. And in the center, what is acting is F cos theta plus n sin theta. This is acting. So now from this we can easily make the we can easily write that as we have broke the forces in the perpendicular direction and in the direction towards the center. So we can now write the equation. Easily we can write the equation. Here F is our maximum value of static friction. Okay, so it will be equal to normal into mg. Okay, sorry, I'm really sorry. Normal into mu. Okay, normal into mu. So now we'll follow this. So here F cos theta plus n sin theta is equal to mv square by r, which is giving the centripetal force, and n cos theta is equal to mg plus f sin theta. So mg plus f sin theta is equal to our n cos theta. Okay, so this we can write it like this. Now what we can do here is, these are two equations which we are getting. Okay, now let's let's divide this equation. Let's divide this two equation. Before that, what I want to do is I want to simplify this second equation, that I will make it f sin theta minus normal, okay, normal into n cos theta, which is equal to minus of mg. This is our second equation. Now let us divide these two equations. So dividing, what we get, f cos theta, no, let us divide the second equation with the first equation. So f sin theta minus n cos theta divided by f cos theta plus n sin theta, which we will get mg by mv square by r. mg gets cancelled, okay, r will go above, so rg divided by v square we are getting here. Now let us divide this two by the denominator and numerator by cos theta. So what we get, if we divide it by cos theta, then we get f tan theta minus n divided by f plus n tan theta. Okay, we are getting in this way, which is equal to our minus of rg by v square by r. Okay, now we know that our this value is equal to, friction is equal to mu into normal, tan theta minus normal divided by mu into n plus n tan theta, which is equal to minus of rg v square. One second, just give me 1 second. R square g by v square. See here, m and m gets cancelled. Okay, yeah. So this will go up and this will be becoming like this. Now what we can do here is we can take normal common. Okay, normal if we take common, if we are taking common, so normal gets cancelled and what is left is mu tan theta. Okay, so here mu is the angle of repose, so tan phi into tan theta minus 1, yes, minus 1 divided by tan phi plus our tan theta. Now here what we are doing, if we make it upside down, if we reverse this thing, is equal to minus of rg v square. Now if we reverse it, what we get is tan phi plus tan theta minus divided by tan phi into tan theta minus 1. Okay, so I want to divide this, I want to add a minus in this place and I want to also add a minus here. So minus gets cancelled and in this case what it becomes, I just rewrite it, 1 minus tan phi into tan theta. So what does this becomes? This becomes a formula for our tan theta plus phi, which is equal to rg square, r square by v square. Okay, so as now we are to find the v square, so we can find, and what our final expression will become is that we'll simplify it and what we'll get to know is our V max is equal to under root of Rg tan theta plus phi. Okay, so this is basically the derivation of our this. Okay, this is the derivation. Now we can also derive in the similar way, and this is your homework to find it out. Okay, I am just giving a basic idea. Its value is equal to Rg tan theta minus phi. So why this minus sign came, that I am explaining, but rest all is your job to find out. So this is our mass M. This is mg acting here. Normal is acting in the perpendicular direction. Now in this case it is moving, and we want to find the minimum velocity. So to find the minimum velocity, what we can say, that here the friction is acting in the back direction. Why it is acting in the back direction? Because its tendency is not that. Here what happens, that its tendency is not that it wants to go to it wants to get out from the track. So its tendency is not that. So can completely understand that is in this case the friction has a different direction. So if this is theta, this becomes 90 minus theta. This becomes 90 degree minus theta. Okay, so what we can say, that if we draw a vertical line, so this is also equal to 90 degree minus theta. Okay, and this is theta. So f cos theta will be acting here, and in the above direction f sin theta will be acting. Similarly, if we break here, so plus n sin theta, and in the center n cos theta will be acting. So we are to now just frame the equation, and we just have to solve it and get this answer. Please tell me in the comments below that whether you have got this answer or not. Okay. So now we are on our last topic of today's class, that is ROC, that is radius of curvature. So now let us understand that what is this radius of curvature. Suppose there is a random path like this. Okay, now what we are told to find here, we are told that if a particle is moving, or if at this point, if a particle is having a velocity v here, in this case, in this point it is having a velocity in this direction v. Okay, so in this case I need to find the radius of the circle on which the particle is moving around, and obviously you can see that this is a circular path, right? So what I want is the radius. I want to find the radius. Okay, so in this case what I do, I hope you have studied that whenever in this case, so we just consider a small circle, as we know that at any point in whenever a particle is doing circular motion, velocity is acting at a tangent. So we are told to find this radius. Okay, this radius, let me represent it by radius 1. So this is very small. This circle we are imagining, but it is very small. Okay, very small. In this, just it is touching at the point. In this case, the radius will be suppose R2. In this case, what is the radius? Is suppose our R3 velocity is in this direction. So can you see that this is the tangent? So we are using such a basic concept. We have learned in our first lecture that whenever there is a circular motion, also I have told in the second lecture that whenever there is a circular motion, the velocity at a point in the circular motion is always makes a tangent. Okay, it is always at a tangent. Velocity is acting at a tangent. So what we can say, we are told to find the radius. Now I will tell you to think. So now let me tell you the solution. The very basic solution is that we know that the centripetal acceleration is equal to v square by r, and we are told to find this r only. Okay, we are told to find this r. So what we will do is r v square divided by a. R is equal to v square divided by centripetal acceleration. This will be our r1. Similar will go for this case. Now in many ways, okay, it can, maybe they may ask using vectors, they may ask also. Now I am also using another concept, that is net acceleration. We can write it as AC square, the magnitude of net acceleration, and the tangential acceleration square root over. So this we can write, right? Now from here, if I want to find the value of centripetal acceleration, what I get is a net square minus AT square under root is equal to my this. So I just put on this value. So our R1 becomes V square divided by root over of A net square minus AT square. So this is becoming our value of R1. Right? It is clear to everyone, I hope. So now we can also, there are many, this is also asked in JEE Mains. So today's class is based on JEE Mains only. Okay, based on the questions which are asked on JEE Mains, because this chapter is not having much weightage in JEE Advanced. Okay, so this is our, now there is also a mathematical formula which will start in which will study in the calculus part, which we'll learn in class 12. So in that case, what we do is we write the formula of radius of curvature is 1 plus dx by dy square whole to the power 3 by 2 divided by the second order derivative of x with respect to y. So this is the formula. So very few questions are observed. Okay, the question rate from this this formula is very less, but still you can remember, and when you will go for your exam, you will be already knowing this formula because it is there in our class 12 maths. So we'll learn this formula, and then we can use it if we are required to use. Okay, so this was our learning for today's class. We'll meet in the next Sunday. So till then, bye bye and thank you.